All right, so the law of cosines is going to be used on two different kinds of triangles. All right, on triangles where we know all three sides, and in triangles where we know two of the sides and not one of the other ones. SAS. All right, so we're going to use this for SSS and SAS triangles, if you care about that. No SSA or ASS triangles. That's the law of sines. That's the ambiguous case. Let's do an example. Example 2. Solve the following triangles. Part A, gonna give you a triangle. Now this looks like alpha, gamma, beta. You can think of these as capital A, capital C, and capital B as well. And A is going to be 10. C is going to be 12. B is right here. And in my notes, I forgot to give you information. I didn't tell you what beta was in my notes, so I guess I'll just make it up. Let's say beta is 32 degrees, 35 degrees. I don't know. All right. We need that information. So first off, I want to show why we can't use the law of sines here. For the law of sines, we need an angle and the opposite side. But we only have one angle and we don't have the opposite side. We can't solve for another angle either. We cannot use the law of sines. This is a side angle side triangle, SAS. Law of sines will not be helpful. Okay, but we can use the law of cosines. We're missing one side and two angles. We're missing one side and two angles. So with law of sines, we usually like to find the angles first. With law of cosines, we usually want to find all the sides first. All right. And the reason why is if we want to solve for an angle with the law of cosines, notice any angle we want, we do need all three sides to solve for that, right? If we want angle C, we need to know what A, B, and C are. And similarly with all the other angles. Then we need the sides in order to use the law of cosines. Okay, so which one are we going to use? Well, we know A and C. We don't know B. So we're going to use this one right here. This is the one we're going to use to solve for B. So let's copy down the law of cosines. Law of cosines says B squared is A squared plus C squared minus 2AC cosine of B. Let me just double check. A squared plus C squared minus 2AC cosine of B. All right, and you can always remember because the one that you're solving for, well, the other two are going to go first, and then it's always minus 2, the other two again, and then cosine of the angle that correlates to the one you're solving for. If you remember one of these, you can remember them all. And then we just fill things in. So B squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 35 degrees. Type that into a calculator, we're good to go. So B squared. And again, it's a really good idea not to approximate until your final answer. You take the square root, that gives you a plus or minus. We're only going to look at the plus because we're not going to have negative side lengths for triangles. You could simplify a little bit, right? 100 plus 144 minus 240 cosine of 35 degrees. But yeah, try not to type it into your calculator until you're done. We're only going to look at the positive one. And let's type it in with Desmos. We're looking at the square root of 100 plus 144 minus 240. Oh, I tabbed out again. Minus 240 times the cosine of 35 degrees. Oh, don't use Desmos. Desmos doesn't like degrees. We can use Google. Oh, nope. So square root of all this. Oh, it's because I just copied it. I shouldn't have copied it because it has the wrong formatting. There we go. It should be about 6.8850. And again, if we're using this b later, we want extra decimals. In our answer, a lot of times the book only wants 2 decimal or 1 decimal place. So in our answer, we can just write 6.9 like that. But it's good to have extra digits because we're going to have to use it later. And now we can either use the law of sines or the law of cosines to finish. Law of sines is usually easier. Okay. One other thing that you can also mention back here for the law of sines is if you want, or the law of cosines, you can also solve each of these for cosine, and there's a formula. I'll incorporate that in the next example. But yeah, it's usually easiest to use law of sines. But after you do this, you can use law of sines or law of cosines. So law of sines says, well, let's choose an angle and its opposite side that we know. It's going to equal, choose either alpha or gamma, and then use A or B and solve this accordingly. All right. So I'm going to rush through this, go through this pretty quickly. It's a good idea to pause it, try to finish this with the law of sines. The law of sines, Jason. The law of sines, and then see if we get the same thing. All right, so sine of alpha equals 10 times the sine of 35 degrees divided by 6.8850, where alpha is going to be approximately equal to the arcsine of that. Arcsine of 10 times the sine of 35 degrees divided by 6.8850, and convert that to degrees. Alpha is going to be about 56.4166. Side note, there is no ambiguous case when you're using the law of cosines, so we don't have to check that ambiguous case here. All right, so this is going to be about 56.4, which means that the last angle is going to be the last one. Last angle is going to be the last one. So gamma, right, is 180 degrees minus 56.4 degrees minus 35 degrees. What does that come out to? I have no idea. Type it in. 56.4. Gamma is going to be 88.6 degrees. Make sure to include units. I dropped my units somewhere. And there you go. That's the law of cosines. The next one is a little trickier, but that's basically what we got here. This is the nicer side, the nicer situation. Side angle side. Use the law of cosines once, solve for the missing side, and then use the law of sines or the law of cosines to get your other angle. And then your third angle just needs to add up to 180 degrees. Final check. The biggest angle should be opposite the biggest side. We've got that. Smallest angle should be opposite the smallest side. Good. It's a good way to kind of check things. So let's look at the other kind of triangle that you could look at in this one, side, side, side. It's going to be part B, where B is 25, A is 20, C is 18. You could label these alpha, beta, gamma, or A, B, C. It's up to you. So now we don't have any angles. And that's okay too. But notice what we're going to have for the law of cosines. We're going to have to solve, right? This time, we're going to have A and B and C, but we're going to have to solve the cosine of C. All right. So in this one, you can choose any one you want, any formula you want, for if you have three sides. It just depends on which angle you want to solve for. Solve for angle C, solve for angle B, solve for angle A. Pick your favorite. This is my favorite. A squared plus B squared minus 2AC, cosine of capital C, equals C squared. Plug things in, solve for C. So A is 20, so this becomes 20 squared plus 25 squared minus 2 times 20 times 25 times the cosine of C equals 18 squared. All right. And it's a little bit of algebra. 400 plus 625 minus 1,000 times the cosine of C equals, I don't know 18 squared actually. 324. All right, well, so combine like terms, move them all over to the other side. It's going to be 10. Whoa, it's not going to be that. It's going to be 1025 minus 1,000 cosine of C equals 324. I'm actually going to, let's just subtract over the 324 and add the 1,000 cosine C. 1,000 cosine C can equal this difference, which is 701. Is that right? 324 minus 1025. What? No, I'm not. No, it's not a phone number. I'm trying to subtract these. Yeah, it's 701. All right, divide both sides by 1,000. You'll get cosine of C, plus 7 over 1 or 1,000. C is going to be the arc cosine. Arc cosine of 7 over 1 over 1,000. And convert this to degrees. 45.4927. There we go. C is about 45.5 degrees. And now we can use the law of sines. All right. Or you could use the law of cosines again. But we now know enough. So again, feel free to pause the video. I'll use the law of sines. You can use the law of cosines. Choose an angle and let's get going. All right, so if we use the law of sines, we're going to have sine of 45.4927 degrees divided by 18 equals the sine of A over 20. You could choose either angle pair. Or in other words, the sine of A is going to be 20 sine of 45.4927 degrees over 18. Take the arc sine. Arc sine of 20 times the sine of 45.4927 degrees divided by 18. Convert that to degrees. 52.4105. All right, good. We got a second angle, about 52.4 degrees. Well, the last angle is easy. The last angle is just going to be B, which is 180 degrees minus 45.5 minus 52.4 degrees. The B is going to be about something. Right, 180 minus 45.5 minus 52.4 It's about 82.1. Here we go. Let's do our final little gut check. Smallest angle, smallest side, biggest angle, biggest side. Do all of our angles add up to 180 degrees? Hopefully. 134.5. Yeah, there we go. Great. And that's how you use the law of cosines. These are only two situations that you can use law of cosines for. All right. If you start with an angle, that's easier. Use law of cosines to find the missing side. If you start with no angles, you can use any law of cosines you want. All right. In this SSS case, you can choose any one of these. Use any law of cosines. I think it's the most straightforward to just do a little algebra like this. But there are formulas that solve it for you, right? If you start with this equation, for example, you can actually just solve for cosine, just like so, right? Just solve it without plugging things in. If you do that, you're going to get the cosine of A is b squared plus c squared minus a squared divided by 2bc. So this formula, and you could derive similar formulas, the book has similar formulas, is more direct. I think it's trickier to plug into your calculator, and I think it's less helpful for remembering. So I'm not recommending it, but it's an option. So you should be aware of that as an option. And again, there's a similar one for cosine of b and cosine of c as well that you can get if you like. This is my recommendation, doing it this way, but my way is not the only highway. All right. That's not the right phrase, but good luck. Let me know if you have questions.